Hello, welcome to my YouTube channel. Today we will learn about how to find zero force members in a truss. So before solving this problem, let us know what is a truss. So if we talk about by definition, truss is an assembly of struts joined together by a pin joint to transfer the load, and that is known as truss. Now in the figure, you can clearly see different members which are joined together by the pin joint to form a truss. Now, the members, I'm calling them struts, they're different from columns. The columns, they undergo different kind of stresses when they are under load, and those stresses are like compressive stresses, tensile stresses, and bending stresses. Now, but when we talk about struts, there are no bending stresses in the struts. Hence, the member undergo only compressive and tensile stresses. In other words, you can say that the member in a truss is under direct compression or direct tension. Now, some of the daily life examples of the truss are like electric towers and the radio towers you must have seen. Now, since we know that what is truss, let us concentrate on a problem to identify zero force members in a truss. So, if you identify zero force members in a truss, how does it help us? The benefits are it simplifies the truss. So when we are calculating forces in various members of the truss, it helps us to simplify the problem by reducing the number of equations one need to solve. So how do you do it? How do you find zero force members in a truss? Now let us understand it by taking various cases. Case 1, non-collinear members with no force acting at joint. Now for example, the truss in the figure has a segment BCD with non-collinear members and there is no force acting at the joint. Now let us draw a free body diagram of the segment BCD. FCB is the force in the member BC and FCD is the force in the member CD. So if the truss is in equilibrium, you can say that summation of all the forces in the x direction for segment BCD is equals to 0. So there is only one force which is FCB. So you can say that FCB is equals to 0. Similarly, for the y direction, you can say that summation of all the forces in the y direction is equals to 0. So there is only one force which is FCD. So FCD is equals to 0. So now you can see that forces in the member BC is equals to 0 and force in the member CD is also equals to 0. If there is no force acting at the joint that is C, this is true for every non-collinear members. When non-collinear members are joined with a pin joint, each member will carry 0 force. Now let us talk about the case 2. Three members meeting at a joint where two members are collinear. So AED with a perpendicular BE is such a section from the truss shown in the figure. Now FAE is the force in the member AE and FED is the force in the member ED, FEB is the force in the member EB. Since no force is acting at the joint, so by taking equilibrium conditions, you can say that summation of forces in the x direction of the section is equals to 0. So in the x direction, there are two forces, FAE and FED. So you can say that FAE is equals to FED since they are in opposite directions. Similarly, summation of all the forces in the y direction will also be equals to 0. So you can say that force in the member BEFEB is equals to 0. So what do we conclude by this? If there are three members that are meeting at a joint with a perpendicular member, you can say the third member is a zero force member. That is, in our case, BE carries zero force in a truss. Hence, these were the two cases that can help you simplify the problem and finding the zero force members in the truss. Thank you.